Good morning, students. This is Junita Mukherjee once again in SS Public School giving you the topic now convection about this convection. I have already told you in detail in the previous video, but we will just learn what is given in the book itself just to make you more understand this particular topic, that is convection. Okay, in the convection what happens, there is a tree we have shown here. In the comparison to the land and in the sea, what happens? Land is much more warmer in comparison to that of the sea in the daytime. Why? Because of the sun, the radiations are coming up, and land is being heated up, and the sea is being little bit started being heated. So land will be more heated, and thus the sea will be more cooler in comparison to that of land. So we are getting a sea breeze in this particular case, which is a form of a convection itself. And in the case of daytime, in the night time, what happens, which the sea is being more heated in comparison to that of the land, because the land becomes cooled down. Here we are getting, when the land is being cooled down, so it will be the land breeze from land to the sea itself. So if it is land breeze, so the water will be more warmer in comparison to that of the land. So we will be getting a land breeze in the night time itself. So these are the two methods in which the convection is being held up in the nature itself. So let us see what is there else given in the convection. Convection is a mode of transfer of heat of actual motion of matter. It is possibly only in fluids. Convection can be natural or forced. In natural convection, gravity plays an important part. When a fluid is heated from below, the hot part expands and therefore becomes less dense. Because of violence, it rises and the upper colder part replaces it. This again gets heated, rises up and is replaced by the relative colder part of the fluid. The process goes on, and this mode of heat transfer is evidently different from conduction. Convection involves bulk transport of different parts of the fluids. It forced convection material is forced to move by a pump or by some other physical measures. Means the common example of forced convection system are forced air heating system in homes and the human circulatory system, and the cooling system of an automobile engine. In the human body, the heat acts as the pump that circulates blood through different parts of the body, transfer heat by forced convection and maintaining it at an uniform temperature. Natural convection is responsible for many phenomena during the day, and the ground heats up more quickly than the land bodies of water. This occurs both because water has a greater specific heat capacity and because of the mixing current disperse the absorbs heat throughout the great volume of water, and the air in contact with the warm ground is heated by convection. This expands, becomes less dense, and thus the surrounding than the surrounding cooler air. As a result, the warm air rises, air currents and other air moves winds to fill the space, creating a sea breeze near land, a large body of water. So cooler air descends, and a thermal convection cycle is set up while transfer heat away from the land. At night, ground chooses its heat more quickly, and the water suffers is warmer than the land. As a result, the cycle is reversed. And the other example of the natural convection is a steady surface wind of the earth blowing in the northward towards the equator, and so called trade winds. So trade wind also is an example of a natural convection, which has already been given in your book itself. So trade winds are what are trade winds? Trade winds are the steady surface winds of the earth blowing in from the northeast towards the equator. So from the northeast towards the equator, the trade winds are blowing, and this is just because of the steady wind on the earth itself. A reasonable expansion is as follows: the equatorial and the polar region of the earth receives unequal solar heat Air at the surface, Earth's surface near the equator is hot, while the air in the upper atmosphere of the poles is cool. In the absence of any other factor, a convection current would be set up with the air at the equatorial surface rising and moving outside towards the pole, descending and streaming in another is towards the equator. The rotation of the earth, however, modifies this convection current. Because of this, air close to the equator has an eastward speed of 1600 km per hour, while it is zero close to the poles. As a result, the air descends not at the poles but at 90° north latitude and returns to the equator. This is what we call the trade winds here. Now, the topic which is being left out is the radiation. As I told you, explained all the things for the convection, and the radiation will be the next topic which we are going to start in the next video. So, moving forward for the next video in which I will explain the radiations. Thank you, students.